At EPFL, we were able to develop and demonstrate a completely new three-dimensional integration technology that allows us to integrate individual chips on top of each other. This technology is perfectly compatible with CMOS chips, and it allows us to mix different species of chips on top of each other, which is called heterogeneous integration. The typical uses of such three-dimensional stacks could be in telecommunication circuits, in implanted medical sensors, and wherever we need very high density for integration. Conventionally, we build chips on a flat two-dimensional surface on silicon. We can always increase the number of transistors we can put on the surface, but as the chip area becomes larger and larger, then the distances between the transistors becomes a problem. And this interconnection distance eventually limits the performance of the chip. On the other hand, if we are able to stack multiple chips on top of each other, we can shorten this distance between transistors, between functional blocks, and at the same time we can increase the integration density. And this is the key element of three-dimensional stacking. In developing this technology, we had to overcome many challenges, and we also had to invent many new steps in order to integrate multiple chips on top of each other. We are able to thin each individual chip down to the thickness of a human hair, and then we form the so-called through silicon via openings, or TSV openings, on the silicon surface. Later we use copper electroplating for forming the electrical connections between the layers. We are able to produce hundreds or thousands of these TSVs side by side on the surface, and when we do the electrical testing, we were able to show that each one of these TSVs are functioning perfectly, which is exactly in line with our expectations.